Okay, average slope on the interval 3, 6. Well, here's 3, and here's 6. So here's the interval of your x-axis, right? And if you want to be complete about it, you put a closed dot on each of these to show it's a closed interval, but that doesn't really matter in this context. Still, a good idea to do it. So, what you get is you get your graph points, right? Okay? And by the average slope, or if I asked for the average rate of change, you'd be doing the same thing, right? Because that's what the slope is. Okay? So you got these points, so you automatically draw your fundamental triangle. That's what I see people doing, so I'm real happy about that. Okay? So now, what do you know about your fundamental triangle? Well, you know that this interval is 3, right? So your run is 3. Your rise looks about equal to the run. I'll bet it's pretty close to 3. Now there are different ways to get the rise. You can just project over and say, well, the rise is from here to here. So how far is that on this scale? And compare that with 10. It looks like we need 1, 2, almost 3 of them to get 10. So I'm going to say that that's it's either 3 or 4. I'm going to say 4. Put a little question mark. Or I could say, well, that looks like about 9, and that looks like about 12 or 13, so it's 4, right? Okay, so we say rise equals 4, so that slope is 4/3, right? So our answers, our estimate of f of 7, f of 7 looks like approximately, where did I get it? It was approximately 13. Yeah, I wrote that up here. So I would write this as one of my answers. Solution of f of x equals 5 is x equals negative 0.8. And I noticed when I wrote this, I did not write my negative on the 0.8, so we got to be careful about that, right? Okay. Then on 3, 6, slope, and it doesn't hurt to note that the slope is also the rate of change, right? And that equals 4/3. So we understand how to use a graph to do these estimates.